All right, in this third video, we're going to work 6 more problems from the review. This will be the last set that we work. We're going to work number 18. Find g of f of x. This is the composition of functions g and f. And basically, g is the outer function, and f is the function we're going to plug into g. So we are given the functions here, and we're going to start with g. So we have 4 over, and where we have the x in the function g, we're going to put parentheses because we're going to plug f into that parentheses. So we have 4 over x plus 3. So where the x was, we're going to write in this 5x minus 3. And then we simplify, and everything on the top is just the 4, so we have 5x minus 3 plus 3, which is just 5x. So 4 over 5x. That one's pretty simple, but remember, it's just a refresher on how to do a composition of functions. The next one we're going to look at on this is 20. We have a publisher with fixed costs of $62,100 on a book for development, editing, and advertising. It costs the publisher $2 per copy at the printer. The publisher charges $25 per copy. Write the linear profit function that represents the profit P of X for the number of books sold. So remember, the profit is the revenue minus the cost. It's what you take in minus what you spent to produce your product. So we have revenue is 25x. It's going to make $25 per copy on each book. The cost, well, the cost of the book is $2 per copy, plus the fixed costs. Those are the startup costs for all of the other stuff beyond just printing the book, so $62,100. And the profit then is this function minus that function. So P of X is 25x minus 2x plus 62,100. This minus has to be distributed through here, so we have 25x minus 2x minus 62,100. And these are like terms here, so I can just subtract those, and I get 23x minus 62,100, and that is our profit function. So 23x minus 62,100, so C. The next one we're going to look at is 21. This is a simple one just to kind of refresh on the logarithm rules. Write the logarithmic equation as an exponential equation. So we have log base 8 of 64 equals x. And again, this raised to that gives us that. That's the basic equation. So we have 8 to the x equals 64. We don't even have to solve for x. We just have to rewrite it, and that one is B. Next, we're going to look at 22. This one asks for the domain and range of a function that has asymptotes. So on this one, the domain has a break in it, and so does the range. And remember that the domain is going to be the x values, and we have a break. It comes up here, and when it hits x equals 1, it just runs alongside here, and on this side it can't ever touch that. We don't have the equation of the function, but there's something that is preventing it from being equal to this, or using this 1 as an x value, but we can see what's going on. So in the domain, it goes from negative infinity over here. It comes up to 1, and it can't cross 1, so we use a parentheses. And then we join that up with what's going on the other side. It starts just on the other side of 1 and goes to positive infinity. And the range is basically doing the same thing. It's coming from below, and it does the same thing when it gets to 2. It doesn't touch 2. It just kind of hugs alongside it. It gets closer and closer to 2, but it doesn't ever actually equal 2. So negative infinity to 2. And again, in parentheses, because it can't be equal to that value. And then we join that up with the piece on the other side, which starts just on the other side of 2 and goes to positive infinity. So for this one, we have negative infinity to 1, union 1 to infinity for the domain, and the range is negative infinity to 2, union 2 to infinity. So this is E. The next one we're going to look at is number 25. And this one is just setting up a matrix. We don't have to solve it. And this is basically just a reading question. Danielle stayed in 3 different cities, Washington, D.C., Atlanta, and Dallas, for a total of 14 nights. She spent twice as many nights in Dallas as she did in Washington. The cost per night in Washington was $200. In Atlanta, it was $100, and in Dallas, it was $150 per night. The total cost for 14 nights, excluding the tax, was $2,200. If X represents Danielle's number of nights in Washington, Y represents the number of nights in Atlanta, and Z represents the number of nights in Dallas. Find the augmented matrix of the corresponding linear system that would solve for X, Y, and Z. We don't have to solve for it here, just find the matrix. So let's look at what we have. First of all, 14 is the total number of nights, and these are the number of nights she spent in each of these cities. So the number of nights in Washington plus the number of nights in Atlanta plus the number of nights in Dallas totaled 14. So one of the things we're going to be looking for is 1, 1, 1, 14. And we see that in a couple of matrices, 1, 1, 1, 14 here, 1, 1, 1, 14 here. So we kind of know we're basically focusing on those two to see which one has the rest of it correct. We have 2 other bits of information. We have the total cost, and we have a relationship between the number of nights in one city and the number of nights in another city. So X, let's see, where were we? She spent twice as many nights in Dallas as she did in Washington. So Z, Dallas, is 2 times X. The number of nights in Dallas is 2 times the number of nights in Washington. And we can turn this into an equation where the X and the Z are on the same side, so we can subtract 2X. And we can write this as negative 2X plus, this doesn't have a Y in it, so we'll write 0Y plus 1Z is 0, because when we subtract 2X from here, we get 0. So this is going to be another row that we're looking at, a negative 2. So this row is going to be a 1, a 1, a 1, and a 14. Here we're going to have a negative 2, a 0, a 1, and a 0. And the third one is $200 times X, which is Washington, plus $100 times Atlanta, which is Y, plus is 150. Z is 2,200. So we have 200, 100, 150, and 2,200. So if we look at the options that we have based on the 1, 1, 1, 14, we're looking at this one. We're looking at this one. Now, one of the things we have to look at here is the fact that this could have been done the other way. And I think in this one, that's what's going on. Instead of moving the 2x over, they moved the z over. So we have 2x minus z equals 0. So that would be a 2 in the x. There are no y's, so that would be a 0, a -1 for the z, and a 0 over here. And that's what we have in this one. So in this one, we have the 1, 1, 1, 14 right here. We have the 2, 0, -1, 0, and then we have the 200, 100, 150, and 2200. So D is the matrix we're looking for. The last question we're going to go over, number 26, and this is the last one on the review. State the solution of the following augmented matrix in reduced row echelon form. So this is in the form that we want, but we're going to look at this for the solution. The key here is that we have the bottom row has nothing. These are all zeros, but this is not 0. So basically what this matrix is saying is that 0x plus 0y plus 0z is equal to 8. But 0x is 0, and this is 0, and this is 0, and that can't be equal to 8. So that's impossible. That means that there's no solution to this system because the bottom row makes a claim that is not possible. So it's a contradiction, and therefore our initial assumption that there was a solution is contradicted by this false statement here, and so that is when we find there is no solution, when we have the reduced matrix and we have a row that's all zeros on this side of the line, and this is not a 0. That is a no solution.